Well, I guess I should start off by saying welcome to Chemistry 2. Also, welcome to our new textbook, Brownell May Burston, Chemistry, the Central Science. Um, this is going to be an introduction. Chapter 1 is a complete review of Chemistry 1. So hopefully you should remember most of this. Alright, so Chapter 1 talks about matter and properties of matter and measurements and units of measurements. Chemistry. Chemistry is the study of properties of materials and the changes that they undergo, or the study of matter. Chemistry can be applied to all aspects of life, even from pharmaceuticals. Leaf changes in the fall. There are several things that chemistry can be used to study, even the gas that goes into your car. In this picture, it kind of gives us a summary slide of the three states of matter in this picture. We have a solid, liquid, and gas, which are the three primary states of matter that we study in high school chemistry. We should remember there's one more, plasma, that we don't study. But we will study solids, liquids, and gases extensively, and specifically how these different types of matter, these different phases of matter, change. Well, everything changes, so we're going to study everything and the changes that it undergoes. Now let's talk a little bit about the scientific method. This should be just a review. It's a structured way to study something, or a systematic approach to solving problems. We first begin the scientific method by observing a problem, something that needs to be fixed. When we observe this problem, we try to get trend patterns, try to see exactly what's happening. Then, once we find out what's happening, we kind of ask ourselves, we make a hypothesis, we make an educated guess as to what's happening. And then, one thing we need to remember about hypothesis is it must be testable. We must be able to go back and experiment on that hypothesis. Now, once we experiment, we make observations again, we find those patterns and trends that they have, then we can modify our hypothesis. A hypothesis may be modified several times, maybe tweaked several times. Eventually, after enough experimentation has happened, a hypothesis may be able to turn into a theory. Now, what is matter? What is matter? Chemistry involves a study of matter and the properties of that matter and the changes of the matter and the behavior of the matter. Well, we really can consider matter is the physical material of the universe. Anything that has matter has mass, and it must occupy or take up space. There are about 100 elements that constitute all matter. Okay? And we have several forms of matter on the board, or on the slide. We have atoms, which we know all elements are made up of atoms, which are the building blocks of life. We're going to talk a little bit more about that in a second. We have molecules, which are combinations of atoms held together in specific shapes. And we have mixtures, which are a combination of two or more pure substances. So, for example, in this mixture, we have one substance. So this is just this is just a compound. In picture D, or slide D, part of D, this is a mixture of elements and compounds and molecules. Okay. Now, atoms we consider the building blocks of life. Atoms, or each element, is made up of the same kind of atom. We have the periodic table of elements that gives us a list, or an exhaustive list, of all the elements on the periodic table. We have an example being highlighted here as oxygen. Why does oxygen have two atoms coming together? Remember, oxygen is kind of special. It's one of our 7 diatomic elements, which we'll talk a little bit more about that later, but you should remember the 7 diatomic elements from Chemistry 1. Now, a compound is made up of 2 or more different kinds of elements. We even have molecules that are made up of different elements. Now, we have several compounds on the board. We have water, we have carbon dioxide, we have ethanol, we have ethylene glycol, which is used in antifreeze, and we have aspirin, which we know is used as a fever reducer, as an anti-inflammatory drug, and as a pain reliever. So, I got a question. Why should we study chemistry? Well, we study chemistry because it has a considerable impact on our society. Anywhere from healthcare, food, clothing, the conservation of natural resources, environmental issues, politics. Chemistry has an overbearing effect on everything that we do in our lives. We study chemistry because because it's part of what we have to learn in life. Chemistry serves not only chemistry, but biology, engineering, agriculture, geology, physics. Any science that you study has to deal with chemistry. Therefore, we consider chemistry the central science. Now, let's talk a little bit about the states of matter. This is how we classify matter. Matter is typically classified by its state, solid, liquid, or gas, or by its composition, either an element, a compound, or a mixture, and sometimes a little bit of both. Solids, liquids, and gases are the three forms of matter that we call the states of matter. Remember, there's one more we typically don't study in high school, or even probably will not study in college chemistry. Properties described on the macroscopic level or the large-scale level typically are the properties. How do we describe a gas, liquid, and solid on the macroscopic levels, or the levels that we can see? Well, a gas, or we sometimes call it a vapor, has no fixed volume or shape. It conforms to the shape of its container. You should remember this diagram from chemistry 1, where you had to draw the molecule, and it was the molecules are very spread apart, and they are filling the shape of its container. Gases are also compressible. Since you have a good amount of space in here, you can also compress these. Now, a liquid has a volume independent of its container. All right? That means it does not depend on its container to hold its volume, which means it can be less than the container can actually hold. It is not fixed shape. It does not have a fixed shape. We know that liquids can flow just like gases can flow. But it does have a set volume, no fixed shape, and it is also incompressible. Now, solids, on the other hand, if you're just looking at it, remember we're talking about the macroscopic level, have a volume, a set volume. We can calculate the volume of a cube, or we can calculate the volume of a cylinder of something, or a rectangle. Several things. It has a set volume and a definite shape. It is typically rigid and incompressible. If you think about your table, it's a solid. It's kind of hard to compress. All right, let's talk about the molecular level, or what's actually happening at the microscopic level. Gas molecules, the actual atoms that are holding molecules apart, are the actual atoms that compose these molecules, are far apart, and they move at high speed, making elastic collisions with the sides of their containers. They collide often with their containers and other molecules. In a liquid, our molecules are obviously closer together, and they can flow past one another. They are still moving rapidly, but again, they can slide past one another. And in a solid, molecules are packed closely together in definite arrangements. So you really aren't going to be able to move those atoms, but you should remember that they are still moving. Now, the classification of matter. How do we determine how to classify matter? Well, there are several ways to do that. I typically use a flowchart. As a matter of fact, if you took me for Chemistry 1 last year, we actually I had a flowchart in our notes as to how to classify matter. The first question that we have to consider is it uniform throughout? Is it the same throughout? Can you see, does it look the same? Are you looking at a block of gold? Is it gold throughout? Or is it kind of different? Does it have specks of something in it? Does it have different colors of things in it? If it is not, then we consider it a heterogeneous mixture. You should remember that a heterogeneous mixture does not have a uniform composition or appearance. For example, sand. Sand has several different colors in it. If it does have a uniform composition, then it is considered homogeneous. And remember, homogeneous is the same throughout. Remember that mixtures are a combination of two or more pure substances. Now, a pure substance um, is matter that has a fixed composition and a distinct property. There are two types of pure substances, elements and compounds. We'll talk about those in just a second. Now, does it have a variable composition? Well, that means, is it a pure substance or is it a mixture? Is it all of one molecule or is it several different molecules? If it is all of the same, or if it does have a variable composition, which meaning that it is not made of the same molecules, then it is a homogeneous mixture, or again a mixture that is uniform throughout, but it might be made of different things. The best example of that is the air in a room. The air in a room is a homogeneous mixture because you can't individually pull out the nitrogen and oxygen molecules, but we know that the air in a room, or the atmosphere, is typically made of about 78% nitrogen and around 20% oxygen and a few other trace elements. Now, if it does not have a variable composition, then it is a pure substance. Which is, pure substances are matter with fixed composition and distinct properties. We have two types of pure substances, and we ask ourselves to separate it like this. Can it be separated into a simpler substance? If not, if it is all one substance, if it cannot be broken apart chemically or physically, then it is an element. We know that there are 117 known elements, but only about 100 of those on the periodic table make up all matter, because around 17 of them are man-made or synthetic. They vary in abundance. We may have a lot of one thing and a little bit of the other, and each is given a unique name abbreviated by a chemical symbol. Typically, your chemical symbols are going to be one or two letter abbreviations. In the latter part, where they have not yet received names, they're 3 letters, but those are Greek numbers. Remember, every element starts with a capital letter. They are organized, or all of these elements are organized according to the periodic table. Okay, so those are elements. Now, what if it can be separated into a simpler compound? Well, then it must, or a simpler substance, then it must be a compound, meaning that we have several elements bonding together to form one of these elements. Compounds are combinations of elements. For example, we have the compound water, H2O. H2O is a combination of elements hydrogen and oxygen. Compounds usually have different properties than their elements. For example, water is a liquid. Well, both hydrogen and oxygen are gases. Water is typically used to put fires out. Hydrogen is very explosive in the presence of oxygen. And you should remember, if in order to have a combustion reaction, you must have oxygen. Okay? And that's a little bit about the introduction to matter and what matter actually is.